It took me 2 years to get that down.
Well, that makes one of us. Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Al Williams.
This is episode 349, Clocks, AI, and a new 3D printer guy. This week in Hackaday News, bad 3D printing news. We usually talk about how far you can get away with 3D printed parts. I know we were talking about it last week. We covered a functional 3D printed carabiner that held up a metric ton. This week we have an airplane crash. The good news is that the pilot walked away with only minor injuries. The bad news is that his kit-built experimental airplane is entirely totaled. And it failed because it had a 3D printed duct on the air intake, and it melted in flight and collapsed, and airplane engine got no more air and stopped right on landing approach, and he ran into that. They have these arrays of antennas to do direction finding, and he crashed it into them. The good news is he's a super experienced pilot and pulled it off without getting hurt. It's interesting to read the British Air Accidents Investigation Report. We have a link to that PDF on our write-up of this. But basically, it looks like the part should have been printed in ABS, was printed in PLA, and it melted.
PLA is generally 55 to 65. I just looked it up. Yeah. So actually, it's worse than PLA, according to...
Test results here of the measured glass transition temperature for the sample was between 52.8 degrees C and 54 degrees C.
Yeah, and that's less than PLA, apparently, so...
You know how it is. The PLA gets hot, it gets a little bit plastic, right? It gets a little bit flexible, and the hotter it gets, the more flexible it gets. So I think there were a lot of comments on this. You know, what is the glass transition temperature? You know, when is soft enough soft enough? And yeah, the answer for your airplane is when it can't hold up to the air intake pressure and collapses on itself. But in other applications, don't get your PLA hot.
It was interesting, too, that he did not 3D print that piece himself, right? He bought it and apparently was misled as to what it was made out of, right? So I always worry about that because, you know, in a commercial airplane, for example, you don't just get to go, oh, I think this part's okay. But I was actually just came up the other day. I was thinking about my neighbor who was putting up a tree house for his grandkids in the tree. And I'm thinking, this is the problem with being an engineer, right? Is I'm thinking, well, how do you know it's going to hold the load that's going to be put under when, you know, 3 kids are jumping on the deck? And they're like, oh, it seems sturdy. I'm like, oh, no, that's not good enough, right? You can't just say it looks good enough. And it's kind of the same thing here. It's like, well, I'm sure it looked fine when you just took it out of the pouch and squeezed on it. But then when you get it hot, well, not so much. So
it does look like the pilot was misled.
So is there any word on whether or not whoever sold him the part, did you buy a roll of something that said, this is carbon fiber ABS for $12 a roll, and then it's not? Or do they think that the people printing it just printed it incorrectly?
Speculation goes wild in the comment section on this one. And I don't think anyone knows. You know, it's known what it should have been, and it's known not to be what it should have been. Was it malice? Was it ignorance? Was it, you know, it says 3D printed, I'll just 3D print it.
Well, and I mean, you know, I don't know about you. I get a roll of filament and I don't do testing on it. Although I will say, if I accidentally run PETG through PLA settings, I immediately know it's not PLA, right? And probably vice versa. But
I had to completely disassemble and clean out the nozzle on my son's 3D printer 2 days ago because he had been running PLA through at the PETG temperatures and it got cooked. And there was a little chunk of charcoal in there.
I have a strong enough extruder that if I run PETG at PLA temperatures, it almost works. I mean, it actually goes through and it comes out and it's roughly in the shape and it just looks like in a cartoon when some character grabs the electric wires and just frazzles. That's kind of what it looks like.
Long story short, if you are 3D printing things and you want it to be functional, you need to know about the material properties of whatever it is you're 3D printing with.
Yeah, a lot of things in cars and motorcycles get hot too. So I wonder how many people are, you know, driving around with something 3D printed that's just a matter of time.
This is a journey into sound.
What's that sound?
What's that sound?
Let's head on off to What's That Sound? This is a brand new sound. We could give Al a chance to listen to it, and you out there can guess along as well as soon as I upload it. Let's see.
Oh. Well, it's rotary.
Mm-hmm.
It's an internal combustion engine, I think.
Okay.
I mean, I'm thinking wood chipper, but it's probably not a wood chipper. And it's obviously something spinning down with something floppy still caught in the rotary part of it. But that's the best I got. Wood chipper.
That's an extremely good guess. It's not exactly right, which is lovely. Means I can leave your guess in without bleeping it out. Those of you out there, if you've got a guess, head on over to hackaday.com/podcast. Scroll on down to what's that sound, find the form, fill it in with your handle and what you think this sound is. And someone will be in the running for next week for a Hackaday podcast t-shirt.
And the good news is your guess can't be worse than mine. So that's good.
Oh, it could. It could. Well, first up for the hacks this week from Jaron McDaniel, bridging RTL 433 to Home Assistant. Now, this is a project that combines a bunch of my favorite things. It uses Home Assistant, which is a nice central brain and user-facing application for any kind of home automation stuff. It's open, it's easy to work with. It uses MQTT to push the data around, which is part of why. And this is making a plug-in for that for the RTL 433 library. And I had never seen this bit of code before. It's absolutely fantastic. Uses the RTL SDR dongle to do not just 433 megahertz encoding, decoding, but 868, 315, 345, all the ISM bands. Because it's a software defined radio, whatever your computer can decode of whatever's going on in the spectrum, it's got routines to decode the signals from this. And so this means things as varied as, wireless doorbell sensors, temperature things. If you've got like a weather station, it probably sends its data over 433 megahertz. Your tire pressure sensors in your car. Just a tremendous range of devices use kind of sub-gigahertz ISM radio to send their data back and forth. And the beauty about doing it with an SDR is that on one hand, it's totally overkill. But on the other hand, this one device can listen to all of these different frequencies. And no matter what kind of crazy device you've got on there using whatever kind of crazy encoding, probably pretty easy to figure that out with an SDR. And then comes Jaron's bit of work here, which is RTL HAOS, that is Home Automation OS, sits in the middle of this RTL 433 library, which does the SDR stuff, and Home Assistant Home Automation library, and makes them work together. And so what this means is that if you've got a home automation system that is fairly smart but doesn't have enough sensors in it, you throw this in and all of a sudden it can listen to anything radio and try to bring that into your system. It just sounds really fun to me.
That is really cool. And kind of as a side note, I'm always really impressed with Home Assistant because it seems like it's sort of a Swiss Army knife that you can extend. And I love software like that. I think I don't want to say we've lost it, but I think we have somehow, what's the right word? We've diluted that over the years, right? So for example, the Linux, Unix type command line is the perfect example of that, where you go, oh, I'll just write a little program that does this, sorts things. That's it. And it'll be useful because I'm going to plug it in with 20 other things. And at the end, I've got an accounting system. We've seen a lot of things like that where you could have these nice extensible plug-in type infrastructure, and either because of the proprietary evilness or you just didn't think of it, it doesn't work that way. You've just got big monolithic globs of code that aren't extensible, and home automation is like a good example of the best of that, right? I mean, it's really, I wish all software was more like that.
Yeah, exactly. It's like they have respect for us, the people using the system, and they made it easy for us to write little plugins for it. And if you have an oddball sensor that you want to integrate into your Home Assistant home automation network, it's just a matter of getting it to say the right things over MQTT to convince Home Assistant that it's a device in its network, and then you're off to the races. And I think that's the particular brilliance of this RTL 433 bridge is that it takes another system that wasn't talking to any home automation networks, but was decoding a whole bunch of wireless device protocols, and it marries them together. And so I just think that's so super clever. And I guess in the comments, some people were like, what's up with 433 megahertz, this kind of sub gigahertz stuff? Is there a lot of interesting activity going on there? And I'm looking around our house. We have a bunch of other things. Our outdoor thermometers all use that to talk to their little base stations.
Yeah, there's tons of stuff. The garage door openers use it. I'm confused about the comments going, well, does anybody actually use that? It's like everything's on that band, it seems like to me.
Everything uses sub gig. Yeah. So I guess what's striking about this is it just kind of takes a whole bunch of things that really should work together, and this is just that bit of glue code in the middle that makes them work together. So kudos, Jaron, for realizing that this need was there and putting the parts together.
Yeah, very cool. Well, my first hack wasn't really a hack so much as BIOS Rhythm had this really interesting web page about something I hadn't seen before. And it's these typewriters from, I guess, around the 1980s or so that weren't really typewriters. They were pen plotters. And so they looked like typewriters. They had a little LCD screen, and you could type in them, and a little pen would go and draw your characters down. Actually, that page has been around apparently for a while, but I asked a few people, have you ever seen these? And only one of them had ever seen one or heard of them. Everybody else was like, what are you, what are you smoking? So I decided it was probably a good thing to bring up. And I was surprised. A few people in the comments actually did have them or remembered them, but I think by far and away, most people were like, oh, never seen that. It's really kind of an interesting idea, especially for the time, because you could have fonts, you could make your letters big, you could make your letters small, you could make them vertical, and of course the good ones could draw graphs, and they could be connected to computers even. So, I don't know. I mean, maybe I'm delusional, Elliot, but I think usually I know all this weird tech from around that time period because I was alive during that time period and buying weird tech, but this one just totally escaped me. It's interesting too that there were a lot of similarities to them, and it looks like everybody who actually made these bought the same mechanism from Alps and then just put their case around it and stuck their name on it. So there really isn't a lot of these, even though there were, Smith Corona, Panasonic, Silver Reed, which is a name I had not thought about in many, many years. And the minute I saw it, I was like, oh yeah, Silver Reed. They made daisy wheel printers later. But I just thought that was a cool tech that had somehow escaped me. I'm always surprised we don't see more people doing stuff with plotters. We all have really high-end plotters sitting on somewhere in our shops or our desk because we've all got 3D printers or CNC machines. All you got to do is mount a pen to them and they're great, right? So particularly if you're doing simple PC boards, I mean, that was an old trick, right? Is to just get a Sharpie and a plotter and draw right on the copper board, stick it in the etch, and you're done. And you don't really see much of that anymore, partially because people aren't making simple PC boards. They're not making them at home anyway. But there's still a lot of fun things you can do with plotters. And just seeing it in that form factor with the keyboard and the LCD, I have to admit, I almost sent this as a tip to Christina because I know how she loves the keyboards and the typewriters, but it was just so cool. I had to write this one up myself. So my litmus test, Elliot, do you remember these? Was this news to you?
I have never seen one of these before. I failed or passed. I don't know which. Your litmus test? No,
I don't know. It's blue, pink. It doesn't matter. It's not pass, right?
Exactly. I definitely am coming out pink on your litmus test. It makes sense if you think about how hard it would have been to do arbitrary graphics back then, in the age of typewriters or different fonts or rotated fonts or, any of that sort of more graphical stuff. But what? A typewriter with a plotter?
Well, the beautiful thing was I linked to the instruction manual for one of them because you realize you could make all those graphs and charts without a computer. So there was some wacky interface that you could say, okay, push this button and it'll say how many is what constitutes 100%? 28. Okay, how many slices do you have? 5 slices. And it takes you through that whole process.
Oh, how cool.
So you really, and can you imagine in 1980 or something, if you'd had a sales proposal and it had all these color charts and graphs and stuff in it, you would think, wow, these guys are, they're balling, right? And now it's like, now who cares? Everybody does that. But that would have been a super differentiator back in the day.
There is something really fun about plotters and just, watching them go And being able to program them is even cooler because then you can do, like all the logo turtle slash generative art stuff that you can't do because your hand isn't accurate enough. You can do in simple code with plotters. Plotters are a hell of a lot of fun.
Many, many years ago, we had a Juki 6100. Juki makes sewing machines, but they also made daisy wheel printers that were brazen knockoffs of Diablo 630s at a bargain price. And we had these long, long data plots to do. So we got continuous feed paper. And because those daisy wheels could proportionally space stuff, you could move the head, if you knew how, like 1/120th of an inch in any direction. So we would move the head and use a period as a pixel.
Oh, nice.
And we would make the most beautiful plots. Now, they took all night, right? But it'd be this 20-foot plot, and it would have beautiful typewritten legends and everything. And it was just amazing. And the dots, the periods 1/120th of an inch apart basically looked like lines and curves, and it was beautiful. Beautiful piece of work.
All right, next up from me, Illusion Manager Reverse Sundial Tells the Time. This is one of two clock hacks that we're featuring today. This one is wild. It's a reverse sundial in that it doesn't use the sun. It has an illuminated LED arrow that points at the sun. And it doesn't just point in the general direction of the sun. It points at it in 2 degrees of freedom, right? Like up, down, and left, right. The tip of the arrow points at the sun. It does this using two motors that control the two different kind of aspects of this. One spins every 24 hours, so it makes a circle around the day, and the other moves as the Earth does its orbit around the sun. That one has a bend in it that matches the Earth's tilt. And so it kind of automatically makes it rise less high in the sky in the winter and higher in the sky in the summer. It's actually a really cool device. You should go check out the video that goes along with it. It actually both goes through a day in time lapse and then a year of noons in time lapse. And that's very helpful in figuring out what's going on. On the kind of practical side, it's a neat build because it uses this like bent brass tube, but it's got a little spring steel wire on the inside that's attached to that motor. So it's actually a really cool mechanism here. Funny enough, he transmits the power to the LED arrow also through this internal spring steel wire and the external brass tube that's holding it at the given angle. And that was a cause of intermittence. Originally, of course, slip rings, always a cause of intermittence. But it's just a really clever use to have it do double duty as physical support, matching the Earth's inclination and transmitting power to the LED. Last up, who knew that you could get LED arrows? It's like a chip on board wire LED arrow straight from AliExpress in that shape. Like I was like, wow, how did he make those? Nah, he just bought it.
That's funny. Yeah, if they just had one with a bump in it so it would go over your head, right, then you could wear it to SuperCon. I found this interesting also. I the two things that had occurred to me, and I will say Tyler wrote this up also, but the first thing I thought of was, well, this is an equatorial mount for a telescope, right? You point at a star and then it moves so the star stays in the view. It's very similar to that. But the other thing it made me think of, and I mean, I'm not big on the art projects, but I know a lot of people are. An Illusion Manager, clearly this is an art project. I especially like the base of the one in the YouTube preview. Well, I guess that's Egyptian or something around the edges. I thought that was cool. The Vikings supposedly did all their navigation because they had something called a sunstone. And I don't know if that's just a legend or if anybody knows what those really were, but it was where they could find the sun even if the clouds were out, right? So I don't know if it was polarized glass or if it's just a legend or whatever, but you could make an electronic sunstone, right? You'd say, okay, I've got an accelerometer. I know where I'm at. I know where the sun is at this time of day. And so I'm going to show you the sun when you're pointing at the sun. Seems like that would be a cool art project, especially if you were like, I don't know, are there Viking recreators that, build ships and go sail them on the weekends? I don't know. But that would be a cool project, I think. You sound underwhelmed.
No, I don't know what a sunstone is.
Well, nobody does. I think that's the thing.
Yeah,
But that was the legend. The Vikings had the sunstones. They could sight the sun when other people couldn't. And that's how they did all their navigation miracles. Well, I promise everybody listening, this is not the start of a new podcast feature called Clock Time, but
Clockaday.
Clockaday. Oh, there you go. That's our new sister website. So my next hack is by Byen, I guess, maybe Byehn, and it's the trace line clock. Hackaday, we have a long history of showing people's clocks simply because, well, it's a pretty easy thing to build usually as a clock. And then the real question is points for style, right? Everybody can show a clock on a screen, but what are the other ways you can do it? This one is just very cool. What I like best about it is it uses the magic of magnets, and I think we just don't do that enough, right? Magnets are, as far as I can tell, magnets are pure alien magic, and this one actually rotates a hand using magnets, and the little blue line just rotates around, and there's a way to tell what time it is from looking at how the pieces line up against the circle. Another thing I thought was super interesting about this, keeping the magnet in place was one part of it, but the other is that it's moving, and so you've got to have no friction, and he actually uses candle wax. Kind of sticks to the 3D printed parts, but it makes it slide very easily. And of course, it's very easy to come about candle wax. So I'd never really thought about that. There's certain things I have where there's load-bearing surfaces of 3D printed parts. I'm gonna have to try that. I think that would be really cool. So I don't know. There wasn't anything particularly awesome about the clock part of it, I think, but the magnetic mechanism of rotating that single hand around, I thought was very cool.
And it needs to be a magnet because, let's see, for those of you not looking at this video right now, there's an internal circle, which is, I guess, the hour hand equivalent, and a circle outside that, which is the minute hand. And this blue piece of plastic, it connects the current hour time with the current minute time. But that means sometimes it has to be longer and sometimes it has to be shorter. So it needed some kind of weird flexible linkage there. And that's where the magnet comes in. The magnet attracts it and gives it that little bit of extra play in the system it needs to not fall apart. Magnets are the way to go. But extra points because they're magic, right?
Exactly. Well, that's the key too, is that, this kind of reminds me of a third of a Delta printer, right? But if you did it that way, like you say, you'd have this big ugly mechanism and, stuff sticking out the top of it. This is super clean looking. Yeah, I was trying to think of a better way to describe it because you're right. This is radio, you can't see it, but the hand, one side of it is pointing at the hour and the other side's pointing at the minute. So, like you say, sometimes it's longer, sometimes it's shorter. Some of the 3D printers now, including one I've got, has where the heat sinks and stuff are held with magnets and the different pieces. And I think that's just such a great idea. We don't often use that, but things you got to take apart a lot. Magnets hold them. It's very easy to get very strong magnets now. If you do them right, they hold like crazy, and yet you can just pull them off, work on the hot end, and plug it back in.
How do they work?
More magnets, more magnets.
Next up from me, a sweet hack by Ancient, volumetric display with lasers and bubbly glass. Now this one was sent in by Hari Waguna. He wrote me in the tips line. He's like, I hope somebody writes this tip up because I want to see you try to explain how this thing works on the podcast. So this one's for you, Hari. This is a 3D volumetric display inside one of those gimmicky bubble cubes, where it's got a bunch of different voids inside a glass cube. The trick here is that instead of making the image with the bubbles, he arranges the bubbles in a very careful pseudo-random pattern, and then he illuminates them with a projector. And this is the part that Hari wanted me to try to explain, so here goes. It's a lot like projection mapping. If you think about the rays from a projector going out and hitting the screen, each pixel goes and it hits a particular point. The magic here is that the bubbles are encased in this, block of glass, not along a flat plane like with a projector screen, but they're displaced from each other also in the Z direction. So if you hit pixel 1, it's a little bit forward, and pixel 2 is kind of way at the back, and pixel 3 is kind of somewhere in the middle. And by knowing the depth of all of the kind of target bubble pixels inside this desk ornament, for lack of a better word, you can illuminate them so that they make a 3D pattern and not just a 2D pattern. And so that's really cool. It's a lot like projection mapping, but it's projection mapping where you care about every pixel going to a different depth and making the picture. And so it's really, really a neat effect. And it's one that we've seen a little bit of before, but never taken to this degree. And the alignment of the projector to the different bubble array in there is really crazy. And this is one of those things you can only do with computers and a lot of planning. This is a purely CNC project. Like, the factory that made this had to be able to put these bubbles all in exactly the right places so that when you look at it from the perspective of the projector, it's just a grid. But then if you look at it from 90 degrees to that, they're evenly spaced throughout the depth of the cube. Really crazy, really great idea.
Yeah, that's wild. I'm glad you explained it because I don't think I could have explained it that well. But the part I thought was funny was with only around 38,000 points, just 38,000.
It's mind-blowing. Yeah.
Just an average day because we had 38,000 points. It's like, I don't know.
He did cheat. Each bubble in there is illuminated by 4 pixels on the display. If he could get the company that made these things to make them finer, he could actually probably have 4 times that resolution.
Yeah, and I wonder that might be the real story here is how do you make those that precisely? I don't know. I mean, do they laser ablate a piece of the glass or?
Yeah, and I think they hit them with lasers from a whole bunch of different angles so that they cross at a very specific point and it gets hot enough there that it ablates on the inside of the thing. You know, it's like tomography but backwards.
But I wonder where does the ablated material go if it's in the middle of the glass? That seems
Yeah, I don't know either.
that makes it maybe interests me more, but it's still pretty cool.
I'm always surprised by the kind of power of bit addressable projectors. Like, when projection mapping was new and cool, that was really amazing that you could put stuff up on the facade of like a building, for instance, and have it match the 3D contours of the building so well that you could do crazy illusions with it. It's really fun. I actually saw, and turns out we wrote up on Hackaday way back in 2008, a kind of intellectual predecessor volumetric projection to this called Wire Map. Albert Huang, who made it, brought it to Hope in New York, the Hackers on Planet Earth conference, and I actually got to see it there. Instead of using pixels, I guess voxels, inside a glass thing, he had 256 different strings that were also arrayed through space like this. It must have been a meter by a meter by a meter. It was a big cube. You could walk around it. And he had these strings arranged in it so that when you looked at it from the projector's perspective again, they were all lined up in perfect lines with each other, but they were spaced out throughout the depth. And he was doing the same trick, basically. He was hitting them with pixels from the projector, and they were lining up perfectly with the strings and lighting them up at different points. And so this made a kind of a 3D display you could walk around. 256 strings, whatever it was a, probably XGA projector back then. It was not very high resolution, but it was still a really awesome effect. Go check it out. Unfortunately, all the videos from the Wire Map project don't seem to be up on Albert's website anymore. If someone finds them, it's absolutely worth a look because it looks like he, walked around the thing. So you can get an idea of the 3D-ness of it. It was incredibly successful. And this way back in 2008.
Yeah, that's cool. I wonder how you could, that's kind of an abstract looking image, right? But could you have a 3D panda waving at the audience or something? I don't know if it would support that or not.
Yeah, this one was good for, basic geometric shapes and waves and mountains and, cool things like that. It was mostly, yeah, like you say, it's low res. Still pretty impressive when you're actually there in person. Anyway, the secret powers of projectors to put pixels out there in the real world, I think, is still kind of under-realized. Like, projection mapping took it pretty far. These two displays are taking it a step further. But you can map things out. You can do 3D scanning. We've seen projects like that. There are all sorts of crazy things you can do with a simple computer projector.
My next hack is from Mike Fernie. And I have to admit, when I saw this post from Maya Posch about engineering that makes the Rode cat's eye self-cleaning, I thought, oh, she should have done that as a tech in plain sight. And then I realized, oh no, it was Mike Fernie who did it. So we were just reporting on it. But the cat's eye, if you're not up on your road technology, when you're driving down the road, it kind of shows you reflections of your headlight so that you can see where the middle of the road is or the edge or whatever. And of course, as you go over them, they make the kind of bump, bump, bump noise that means, oh, you fell asleep again. It's hilarious to me because it's a very simple thing, right? It's a little reflector. And the key point that Mike is showing is that it's got a rubber dome that if there's any water below them, you basically wash the lenses of them off every time there's some rain and somebody runs over one of them. So they're basically self-cleaning over any period of time. What really interested me about that, and somebody said it in the comments, that's all you needed, right? There's all these things that you can do if you just go, oh, I could simply do this. I saw a machine one time to fill wine bottles, and it was just a font and a siphon and a hinge. So you put the bottle on the siphon, the hinge pulled it down. It was below the level of the liquid. It filled up to the level. You pulled it off, the hinge pulled the siphon back up, right? That's it. No electronics, no valves, no microprocessor. We forget that, right? I mean, there's all these things that you can do. And if you told me today, hey, I got this idea, we could put these things on the street so people could see and they need to clean themselves. You'd say, oh, well, we'll have to put this little thing in there to wipe over the lenses, and we'll have to have a beacon on it, and we'll have to have a solar cell because we don't want to change the batteries on them every 3 weeks. And no, turns out you don't need it at all. So Alloy Dog pointed that out. Somebody said solar power cat's eyes. And somebody said, well, why? These don't need any power, no electronics, and they'll last for decades, right? They just sit there and they just do their job. I think that's my New Year's resolution for 2026 is to stop and think, what am I doing this in the simplest way I could possibly do it, or am I overthinking it and putting all this stuff in it? Because, this is one of those things where you don't want to do it with a 555, right? It's just, why not just do it passively and come up with a clever mechanical design and you're done?
It's such an imperfect mechanical design because it relies on people driving over the middle of the road to activate them. And it relies on the little pockets underneath being filled with water and relatively clean water at that. Like, I think this must be one of those systems that only works in England where it rains too damn much and people are like driving across the dotted line all the time because imagine
because they're on the wrong side of the road.
Imagine trying to do this in Arizona, right? Like, there's no rain ever. You just get those little pockets filled up with dust. And then the one time that like a semi rolled across the middle of the lane, it would be like bash, 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 bash and crush the thing into the dust and like grind the little beads up even more. It's a very particular solution, and it's a very... Like, how would you even model how frequently these things get cleaned? How often do people drive across the middle of the road and hit one, et cetera, et cetera? It's one of these things that if you were an engineer trying to like quantify how effective this mechanism is going to be, it would drive you crazy. On the other hand, your point is it seems to happen enough that these things seem to be clean enough that they retro-reflect. So good job.
Just to play engineer here, if you said, oh, we're going to put them in Arizona and that's untenable, well, I could still have a truck that's made to run over them and spray water in front of it, right? Or, you could have a little caravan. I could have a caravan, a water spraying truck, and a truck to divert traffic out of the lane that I'm getting ready to cross into and just drive, right?
One truck to spray water, one truck to run them over and depress them down into it. Yeah, fair enough.
And so that would be cheaper than still having a bunch of little autonomous mechanisms or sending Joe out there to scrub them. The railroads do something like that. They have to monitor the gap between tracks. And it used to be, way back when Joe drove his little jack car down the track and stopped and got his measuring tape out. And now they've got those trucks that have the railroad wheels on them. I'm sure you've seen those. They can put them down. So they drive up, they put the wheels down on the track, they drive over the track. The GPS tells them when they're passing over the gap, and the optical sensor measures the gap. I'm not going to tell you why I know this, but and then so at the end of the day, they get an Excel spreadsheet that says, well, this gap was 28 millimeters, and that's in spec, so it's green, and so on and so forth. So I think you could still get away with it. It's just a different operational scenario than if you've got drunk drivers in the rain all the time. So.
All right, for my first quick hack, I got Vincent Wynn's production KiCad template covers all your bases. This is a crazy beginning to end CI/CD workflow that integrates KiCad in with the GitHub Actions, and it produces the full line of documentation for your project kind of automatically and as you update it. It's got different like life phases. So when it's an early prototype, you put some variables in this YAML file and it knows to produce these outputs. And then when you're finally done, you can tell it, production, and it produces the whole gamut of documentation out. I can't imagine needing all this much documentation for a PCB project ever. But it's so cool to have a workflow laid out that uses a program called KaiBot to do this for you. That if you wanted to do one part of this or another part of it, you could pick and choose. So really, really cool. And thanks, Vincent, for showing us how you do it. Next up, Tansurat Akinci, RP2350 done framework style, is a little plugin that basically gives you a microcontroller attached to your framework laptop. And the frameworks have these expansion ports which are based on USB-C. This is just a little dongle that plugs in there, connects the RP2350 module to it, and gives you all sorts of GPIOs and all the peripherals coming out of your laptop. It turns your laptop into the Hacker Dream laptop that you want it to be. And I love that. Tansirat actually wrote in and pointed us to a library they've developed for this, which is a native Python library that lets you command the microcontroller from Python on your laptop. This is a really cool project and just a great hacker tool. And last up for me, Voria Labs' Neat Techniques to Make Interactive Light Sculptures is a look behind the build, especially here, the electrical design and build of some really cool Voronoi style interactive LED wall panel art pieces. There's a lot to go into here, but one of the secrets to his having the LEDs always look right is they've got light intensity and color sensors on them, as well as super high bit depth LEDs. And so they are constantly adjusting themselves to the way the light is in your room so that it always looks just right. Very, very cool.
For my quick hacks this week, Diching has the super simple dead buggable Bluetooth chip, which is proof we live in the future because you can get a chip and about 2 or 3 parts soldered right to the leads of it, and you've got a Bluetooth solution ready to go, no muss, no fuss. It's actually based on the cheap, what is it, the CH, whatever those microprocessors are that are so cheap. And since we didn't have enough clock goodness in the main part of the show, Edison's Science Corner has something I've often thought this would be a cool project, and they did it, is the LED hourglass, right? So it's, it's just what it sounds like. It's an hourglass, but instead of sand, there's LEDs that light up from the top and flow down to the bottom. And finally, Stephen Wolfram had a blog post about a new service from Wolfram. And I can't tell you, Elliot, how many times when in the 80s or 90s, when you'd see some article about, a Cray or the Iliac 4 or, the big supercomputers of their days, and you would say, boy, I'd love to be able to have some time on one of those. Now, I don't know why, right? Because because now I've got computers sitting in my office that are 10 times more powerful than those, probably more than 10. And I don't know what I'm doing with them. I don't, all these things that you thought you were going to do. I mean, it's kind of like when you say, oh, I really wish I had a microscope. And then you get it and it's like, well, what am I doing with it? So if you still have need for super duper computing power, Wolfram has made it really simple to be able to say, well, here's something I'm doing in Wolfram anyway, like Wolfram Alpha. Hey, go run that on I think the biggest machine they have is 1.5 terabytes of RAM and 192 cores. Now, yeah, they'll charge you for it, but it's not, compared to what it would cost for you to put that machine together and run it, it's not terribly expensive. What was interesting about the post, too, is he shows how he runs a problem on like the biggest machine. I don't know if it was the absolute biggest, but 192 core machine, and it costs $55. But then he runs it on 500 1 terabyte, 1 gigahertz machines, single cores, and that costs a lot less, right? And it still did the same work. So you can kind of custom what you need to do. It actually lets you pick between parallelizing against a bunch of cores or a bunch of computers or both. So if you're, simulating the atom or the brain or something, this might be cost effective for that. I think for the rest of us, it just goes to prove we don't really need supercomputers.
If I had that much computing power, I would simulate the global weather. And
There
here
you
I
go.
am checking my email. Well, it's time for our can't miss articles. These are long form pieces written by our fantastic Hackaday writing staff. This week I picked Dan Maloney's story of him finally getting a 3D printer. Ask Hackaday, solutions or distractions. And so I guess that was a little bit of a spoiler. Dan has a real project that he needs to get done, and it involves firing up a generator in the wintertime automatically. And he needs to build some custom mechanical bits for it. Half of you out there are saying, oh, it's easy. You just 3D print it. Dan doesn't have a 3D printer yet. Or at least at the beginning of this article, he didn't. By the end, he does. And his story is the story of not succumbing to the great hacker illness slash temptation slash joy of buying a cheap project printer and trying to make that work instead of focusing on the project you've got right now. And we were talking about this, all of us together, and I think it's really great that we live in a time where you can just buy a turnkey 3D printer for not even all that much money. Like, it used to be incredibly expensive to buy something that would just work straight off the ground. And nowadays, it's still 2 or 3 times more expensive than getting something cheesy that you might have to put a little elbow grease into making it work. But it's not much worse than that. And that is superb. And so this is really Dan just kind of talking about this problem, whether you need to get the thing done or whether you want to learn something along the way. And here it's just, he just wants to get it done. And the comments are, of course, full of people experiencing the same thing. It's funny, he name drops me in here as trying to get him to pick up a used, returned as defective printer, because I've had really good luck with that for both me and my son. And it's actually Al's fault that we did that. So here we all are sitting here talking about our bad printers. My son and I got super lucky. Both of ours worked, but mine had a defective touch sensor, and I had to get a new touch sensor for it. And if I didn't have a lot of experience with 3D printers, figuring out that it was the touch sensor that was defective would have been a very difficult hurdle. So, if I were new to 3D printers, one of the two of ours would have worked, not both. And so it's that sense where Dan's like, I'm just gonna get one that works, print the parts I need, and move on. I'll play with 3D printers later. Right now, I need to get this generator fired up in the winter.
Yeah, I bought a bunch of those for a 3D printing class I was doing. And, you're right. I got some that looked like they had never even been opened almost. And then
Yep.
I got one that had bad Z limit switch. I mean, it was a, micro switch. And it takes us 5 minutes to do that because we know, oh, yeah, there was a micro switch that didn't hit there. And that's what a micro switch looks like. And I know where to get them. If you're newbie, that's not going to work. And then one of them looked like it had been run over by a truck. I still managed to get it to work. It was actually not as bad as it looked, but it was missing a few pieces of hardware, I guess, to get it stuck in the box. And it was odd that you said the touch sensor. The touch sensor was broken, but I was able to fix it in place, right? I basically epoxied it back together. It was just the case around it. The touch sensor itself was fine. It was just the plastic case. So I've had a good track record with those too. But I do like Dan's take, which is you don't always have to go from first principles, right? You don't have to go, I'm going to build a radio. First, I need to mine copper and draw it into wire, so I can wind my coils. I'm surprised how often I see this in the business world. I don't want to give out too many details only because it would embarrass the people involved, but I had somebody approach me a while back and said, oh, we've got this genius startup company and there's this process and it's amazing. But the first thing is none of the commercial controllers have the ability to do what we need. So the first thing we're going to do is build our own control system. And I'm talking like a big control system, like for chemical plants and stuff. And we want you to help us with that. And then we're going to sell that too. And we'll make a lot of money on that because ours will be better. And I'm thinking, really? So, all these people, Honeywell and Applied Automation, and all these people have spent years and millions of dollars perfecting this. And you're going to get me in a garage and we're going to beat them with a better controller in 3 weeks and everybody's going to abandon them and come to us, right? Yeah, probably not, right? Maybe you should focus on your great process and surely there's a way to get a commercial system to build that. So I obviously didn't take them up on that offer, and in the end, I don't think anything ever came of that. But you really got to focus on your, in a business case, your value proposition. In this case, it's not exactly a value proposition, but Dan's goal is not to get a 3D printer running. So I think that was a smart move on his part. Although, like you say, he did get a 3D printer, but at least it's something that is fairly, plug it in, push the button, parts come out of it.
Yeah, I got my son one of these cheap returnware one that you'd suggested, and it was such a great experience. And then he's been talking to all of his friends about it. And I'm like, dude, they might not get so lucky. And they don't necessarily all have parents who understand 3D printers who can help them with it. Just came to me and he's like, one of his friends is getting a printer. And I'm like, uh-oh, did you convince him to do something silly? And he's like, no, he's going to get a insert turnkey 3D printer model name here. And I'm like, shoo, because you really don't want someone who's young or new or starting out with their first 3D printer or, like Dan, has a pressing deadline and a project to get onto, starting off with something that is a project. And I do think that's worth noting. When to say, okay, this is a part I don't care about, I'm going to buy that out, get that working, and then get back to the part that's the hard part. That's the hacker equivalent of what you were saying. It's kind of like the hacker not invented here syndrome or something, right? Like we feel like because we could assemble a 3D printer from a kit, we have to. And I think it's useful to every once in a while say, no, you don't have to make your entire PCB etching workflow if you don't want to. You can actually just order the damn parts and get someone to make them for you. Which is not to say you shouldn't be making your own PCBs. It's awesome, and you can get them done
if you want
significantly
to.
faster, and all
if
of this. But
to.
there's a lot of startup there, and you have to want to do that too. And so, is the journey the destination, or is the destination the destination? And knowing that up front and being honest with yourself about that, I think that's the point of Dan's article here, and it's a step toward productive hacker maturity or something. What do I know?
So are you old enough to be playing the big favorite old hacker game yet? I've been there for a long time where, somebody says, oh, I've got my PC boards in the other day. And you go, oh, you guys with your ordering your PC boards, we used to have to make ours using toner transfer. And somebody says, toner transfer? We had to, and next thing you know, the guy's like, ferric chloride, you were able to buy that? We had to make our own out of bleach. And, so you just keep going further and further into the weeds there. But I think it's the natural evolution of things. But I mean, that's a favorite game, and it's software and it's hardware where you just go, oh, you had paper tape. We would have killed for paper tape, And,
exactly. Yeah.
That's the hacker equivalent of talking about your medical ailments, I think, right? When you get old, you sit and complain about all the luxuries the kids have now.
It's uphill both ways in the snow. Yeah. But it's true that 3D printers were that way just 15 years ago, I swear. And so stoked they're not now.
Well, my can't miss this week was Maya Posch's Why LLMs Are Less Intelligent Than Crows. I've ripped Dan Maloney, many times for his tagline of the LLMs are the worst summer interns ever. And I think there's a lot of truth to that. But Maya really has a different take on it. She's trying to show how scientists have characterized what we think of as intelligence. And it's really not just one thing. It's not just, oh, you're smart. You're the professor on Gilligan's Island. You just know everything about everything. There's different types of intelligence and cognitive abilities and how we don't always understand that in ourselves. And I think that's something I've long suspected. Can I prove that computer's intelligent? Hell, I can't prove you're intelligent, right? Much less that, no, I don't mean you specifically, but, generic
Ouch,
you.
Man. Ouch.
Yeah. Sorry, Elliot. You can't prove anybody else has any thought process whatsoever because we're all locked in our heads. And so the scientists working on that, it's kind of interesting, but also they show that animals have some of these cognitive abilities. And she goes into a bunch of really interesting cases, crows manipulating public faucets in Japan, and bears trying to escalate the garbage war in the national parks, right? They'd rather eat your garbage than forage for food. So they lock them out, but then they figure out how not to be locked out. And just things like that. We ask whether or not computers will be intelligent, and we could probably argue that in some dimensions, they're already more intelligent than we are and have been for a long time, right? A computer can add a column of numbers way faster and better than any of us can. And so that's a dimension. It's just not all of it, right? And so when you start looking at it as a fusion like this, we still win on summation, but I think there's some of these we're already losing at, and maybe that's always going to be the case, right? Maybe we'll never get to the point that the machines win on all of them. Maybe they will. I don't know. It's something I've thought about a lot. I mean, I was very interested back, 30 or 40 years ago. They were teaching primates language. And of course, primates can't speak because they don't have the vocal equipment, but they were teaching them like sign language, or Yerkes had the computer keyboard. I forget what kind of primate it was, but some primate was pushing buttons. That is such an emotionally charged piece of science because you'll see it, and just as a layperson, you go, yeah, that monkey knows, give me apple that is yellow and it wants an orange. It obviously was able to figure out what those words meant and understood they applied to an orange, even though they didn't know the word orange. But a lot of people in the scientific community, oh, no, that's just, no, humans are the only people who think, and there's no other way. We see that a lot now, too, with it's a big craze on the social media where people get their dogs soundboards. Have you been seeing that?
No.
Yeah, they give the dog soundboards and they teach the dog, like, if you want to go out, that's the blue button. And some of them
Oh,
are pretty
yeah.
sophisticated, right? They'll go up there and, I would like a treat and to go outside or something. And they push the buttons. Is it clever hands? Clever hands being the horse that was supposed to be able to do math and turned out was not the case. Or is it really that they understand the blue button means I get a treat? And is that language and is that intelligence? I don't know. But it's certainly something. I occasionally write science fiction and even less occasionally sell it so that it gets published. But, I've got a story about that, about what does it mean? I can't prove you're intelligent. How can I prove the machine's intelligent? How can I prove the machine is more or less intelligent than you when I can't even prove the two people, one of them is more or less intelligent in a broad sense? And I think this really fits in well with that. I really enjoyed the article. It's not the typical Hackaday techie kind of thing, but I thought it was well worth the read.
And it's a super good lens to look at the LLM fad. Oh, I said it. That's going on right now. And I was dabbling in AI stuff back before it was fashionable, back before it became what is now called machine learning. And back then, the goal was really different, was really to not build systems that you train once on a big data set and you just run over and over again, but to build systems that inline learned along the way and could, acquire knowledge by running. And so if you think about like a kid comes out, they don't know anything. They eventually learn how to ride a bike. They learn math. They get smarter by learning new things. And that's in super stark contrast to the way these LLMs work, right? They have all of the internet as a data set and they train on it, and then their weights are fixed. And then they just run through the motions over and over again. I think it's very useful to look at the kinds of different intelligences and the way we think about human intelligence when you're asking yourself, are these LLMs AI? Are they artificial intelligence? And are they ever going to be intelligent the way we think people are intelligent or the way we think crows are intelligent? Do LLMs learn from their environment? No, absolutely not. So that's acquired knowledge and reasoning checked off of this box, right? It's not intelligence, really. That's not what we think of as intelligence. Like you said, there's tremendous amounts of knowledge distilled. And so, when you ask an LLM questions, 90-something% of the time, you get a plausible answer back. And some of the time, it's even right. If you condensed all of the internet and were able to ask it questions, of course, you'd get good answers out of it. But of course, you'd also get crazy stuff every once in a while. And so that's kind of no surprise. But it's not learning from its interactions with you. And that's the sense in which the LLM style machines aren't intelligent. Kind of the opposite side, the machines that attempt to learn along the way, the reinforcement learning paradigm hasn't gotten as successful, as quickly, certainly, or at least not as hyped as the LLMs have. And that's kind of the line of research aimed at making the models get better as they get more experience in the world. And that's a really cool project. And I think that's the one that's gotten short shrift in the press lately. I don't know. It's really neat to look at the different ways you can tease these apart and say, is this model doing this? Is this model doing that? And will it ever be intelligent if it's never learning?
Well, and I think the problem is too, is all of us, even take the smartest person you know, they don't match all of these with the same skill that somebody else does. And so I will tell you where I got some very objective proof that I'm wired funny. Not that you needed that. I know you knew it already.
Tell me more.
But the objective proof is what I was after. I play some of these games on the New York Times every day. They got the computer games. They got I'm sure everybody knows Wordle, but they've got one called Connections. So Connections has a bunch of seemingly random words, and they group together in 4 groups of 4. The reasons they connect together are often very obscure, very weird ways, right? So, it might be like, just to take a simple example, it might be bacon, eggs, sausage, and orange juice, and that's breakfast food. So those 4 go together, but then there'd be some other things, and a lot of times they're made to be very confusing or very obscure. I will work that, and at the end, it'll let you see how you did compared to everybody else. If I have trouble and get a lot of mistakes, they'll say, that was an easy puzzle. 85% of the people got it.
Exactly.
And I if I did get it, I'll look, and they give you enough statistics on it. It's really cool. I'll look, and I will get the hardest ones first, and then get the easier ones later. But then sometimes I look at it and go, oh, bam, 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 and in 15 seconds, I'm done with no errors, and I go and it'll go, this one was extremely tricky. Only 12% of the people got, And I'm like, that's crazy. So, I mean, to me, that's objective proof that my brain is not wired up like the statistically average brain. Not saying it's better. I'm just saying it's different. So I don't think it's a stretch to say, oh, we're going to have a computer that's really good at doing X, and maybe we decide it's intelligent at doing X. But it's not intelligent at doing Y, and it's not generally intelligent. And I think the key thing that none of this measures is creativity. So, I've been on that jag for a while. I did a talk at a university, I think about a year ago, where I talked about there's generative AI, which everybody likes to talk about, mainly because most people are too lazy to create stuff. But then there's assistive AI. You don't hear as much about that, right? So you think about it, like a spell checker is assistive. Not that it's AI, but it's assistive. You don't go, I'm going to write a novel, so let me ask the spell checker how to start it out. You just use it to check your spelling. That's assisting you. The example I used for that was actually a piece of science fiction where I asked ChatGPT or one of them, write me a story about a robot that wants to be a teacher and the school board won't let them or something. And it wrote this just pablum piece of, feel good. Oh, the robot asked nicely and it was one of those things. If a 5th grader had written it, you just thought, well, this is pretty good for a 5th grader, but it's for a 5th grader, right? And then I wrote a piece, the same piece, just the opening. I didn't write the whole thing, but I wrote, where it was like an angry robot squaring off against the school board and it storms out of the room and threatens them and all this. So which one are you going to finish reading? Well, you're going to finish reading mine, if at all, right? Because it was tension, and it was what happens next. As Ben Bova calls it, lighting a fuse in the mind of the reader. ChatGPT doesn't know how to do that, and my guess is unless we have a completely different shift in how these things work, it will never know how to do that. I've said that for a long time too. If you want to build something that works like our brains, it's going to have all the same problems we have, and that's not, that defeats the purpose, right? If you've got a computer that's, what was the Red Dwarf had the toaster that was, it was intelligent toaster, and it was obsessed with toast and annoyed everybody. That's going to be what happens. We're going to make intelligent machines, and they're going to be no better than us, and it's going to annoy the hell out of us. So, but it's not using this technology.
In the far future, when we actually do get artificial intelligence and it actually does reason and learn and acquire knowledge, we're going to look back at this phase where we were calling all of these things AIs. And like take the diffusion image generator models, right? Like they're really awesome. They make the craziest pictures out of random noise by having been trained on pictures being degraded into random noise and just running it backwards, right? Or you have the LLMs, which are pick a bunch of words / tokens in a row according to the probabilities that they all fit. And if you have enough parameters and if you have a long enough token space, this puts out text that sounds totally plausible. Neither of these are anywhere near learning or reasoning or anything that we think of as being intelligent. And I think if we did have learning intelligent computer systems, we will look back at this time and go, what were we thinking? We were watching puppets and we thought it was human actors.
I'm going to put a link in the show notes if you don't mind. I hate to keep hawking Stephen Wolfram, but at
I'll do
2023,
it.
he wrote a really good
Yeah.
post on what is ChatGPT doing and why does it work. And he really breaks it down probably in more detail than most people want. But I loved a quote in there. I should have looked it up before I opened my mouth. But he basically says, this works surprisingly well and no one can adequately explain why.
Yeah, that's right.
And I think that's a good summary of it. It's just surprising that it works as well as it does and no one really understands exactly why.
If you ingested all of the internet and stored it in some, 30 billion parameters, you would be surprised that you got sense out of that?
I'm doing this from memory. I think what he was really talking about was the fact that it's not like a Markov chain in the fact that you don't go once upon a, what's the next word? Well, it's always got to be time because that's the most likely thing. It'll go once upon a, well, time's the most likely, but there's also chair, cloud, mushroom, and randomly we'll pick mushroom this time, right? And that's the point that he says that surprisingly works better than just picking the most likely thing every single time. I think that was the context of that.
Yeah. And the weakness of, the simple Markov chain model is that, you've got one word before or two words before or whatever. And then if you try to explode that up to be 20 words of context or 1,000 words of context, you get this matrix of probabilities that's so gigantically dimensional that it ends up being basically empty. And it ends up being like a horrible statistical property, whereas these models do seem to scale up well like that. And so that part is true. Picking clever tokens is part of the success, and the whole attention thing is actually really clever. There's a whole bunch of really neat nitty gritty in these models in terms of what makes it so that they can work. And so I totally agree with that part. But is what they do intelligent? I think the answer is no. It's not artificial intelligence. It's, large language model.
Yeah.
It's what it is. That wraps it up for this week's Hackaday podcast. Thanks very much for listening. If you have any tips, send them to us, tips@hackaday.com. And to follow along with the links in this show, head on over to hackaday.com/podcast. And until next week,
Keep those hacks coming.
clocks, AI, and a new
And you're not hearing those chimes, are you? I think they're just in my headphones.
Congratulations. You are breaking up and super robotic.
Which was my worst fear. Do I sound okay now?
You are unintelligible to me, unfortunately. There. I don't know. I'll just cut that in and it'll work.
We're going to just replace you with the AI narrator, Elliot. That'll be